Good morning, students. I am Savita B, working as Associate Professor in the Department of Mathematics. In this video, I shall explain matrix inversion method to find the solution of system of linear simultaneous equations. This video is useful for 5th semester BSc students. Matrix inversion method is one of the direct methods to solve linear simultaneous equations. Now consider the system of linear equations. a1x plus b1y plus c1z is equal to d1. a2x plus b2y plus c2z is equal to d2. a3x plus b3y plus c3z is equal to d3. So we have three equations in three variables, namely x, y and z. Now write the coefficient matrix. Let us write the coefficient matrix, which is denoted by A equal to a1 b1 c1, a2 b2 c2, a3 b3 c3. And capital X is a column matrix X, Y, Z. And D is again a column matrix whose elements are D1, D2, D3. Therefore, this system of linear equations are equivalent to the matrix equation AX is equal to D. A into X is equal to D. Now it is required to find the solution of this system of linear equations using matrix inversion method. So we multiply both sides of this equation by A inverse. So we get A inverse into AX is equal to A inverse into D. That is A inverse into A into X is equal to A inverse into D. But A inverse into A is identity matrix. Identity matrix into X is equal to the matrix X itself. Therefore, left hand side is equal to capital X, that is equal to A inverse into D. So, multiplying both sides by inverse matrix A inverse, we get X is equal to A inverse into D. Now, what is X? X is a column matrix X, Y, Z. We have to find A inverse first. Multiply A inverse by column matrix D1, D2, D3. Okay. What is A inverse? How to find A inverse? A inverse is equal to adjoint of the matrix divided by determinant A. Adjoint of the matrix A divided by determinant A is equal to A inverse. So adjoint of the matrix A is denoted by the matrix A1, A2, A3, B1, B2, B3, C1, C2, C3, where A1, A2, A3, etc. are the cofactors of A1, A2, A3 and so on in the determinant of A. Then divide the adjoint by its determinant. So we get A inverse. Multiply A inverse with the matrix D. Then equating the values of X, Y, Z to the corresponding elements in the product of, on the right hand side we get the desired solution. That is, on the right hand side we get a matrix of order 3 cross 1. So equate the values of X, Y, Z on the right hand side to get the desired solution. So this method is known as matrix inversion method. So in order to find the solution using matrix inversion method, it is required to find A inverse using adjoint A divided by determinant A. And this matrix inversion method fails if determinant A is equal to 0. That is, A If A is a singular matrix, then matrix inversion method fails. Hence, if A is a singular matrix, then determinant A is equal to 0. Therefore, we have to adopt some other method to find the solution of system of linear simultaneous equations. I hope it is clear. Now let us solve one problem using matrix inversion method. The problem is, solve the equations using matrix inversion method. 3x plus y plus 2z is equal to 3. 2x minus 3y minus z is equal to minus 3. X plus 2y plus z is equal to 4. Now first let us write the coefficient matrix. Coefficient matrix is 3, 1, 2, 2 minus 3 minus 1, 1, 2, 1. Find determinant A. Find the determinant of the coefficient matrix. Determinant of the coefficient matrix is equal to 8, which is not equal to 0. In other words, the matrix A is non-singular, hence we can use matrix inversion method. Okay. Next step is to find the cofactor matrix of this matrix. How to find the cofactor matrix of A? Let us begin with the minus. The minor of 3 is, how to find the minus? Delete the first row and first column and evaluate the minor of order 2, that is minus 3 plus 2. Minus 3 plus 2, that is minus 1. Okay. So first element is minus 1. Then consider the second element. This is 1. This is in the second column and first row. So delete them. So deleting the first row and the second column, we get a minor of order 2, whose value is 2 plus 1, which is equal to minus 3. Now since it is in the first row and second column, it is multiplied by minus 1. Therefore, second element on the first row is equal to minus 3. First element is minus 1. Second element is minus 3. Now let us consider the third element in the first row. It is 2. Delete the third column and the first row. Evaluate the minor of order 2. 2 into 2 is equal to 4. 4 plus 3 is equal to 7. So we have 7. Therefore, the first row elements are minus 1, minus 3 and 7. These are the elements of cofactor matrix. Okay. Now let us consider the second row elements. 2 is the first element in the second row. Delete the first column and the second row. So we have a minor of order 2 with elements 1, 2, 2, 1. Evaluate 1 into 1 minus 4, that is minus 3. Since it is in the second row and the first column, we have to multiply by negative sign, that is multiply by minus 1. Therefore, this element on the cofactor matrix is equal to 3. So first element in the cofactor matrix is 3. Okay. Then let us consider the second element in the second row. Delete the second row and the second column. We have 3, 2, 1 and 1. Evaluate 3 minus 2 is equal to 1. Therefore, second element in the second row of the cofactor matrix is equal to 1. Let us let us find this element. Minor of minus 1 is equal to, eliminate this column and this row. We have minor 3, 1, 1, 2, that is 6 minus 1 equal to 5. Since it is in the second row and third column, it is multiplied by minus 1. Therefore, we get minus 5. Hence, minus 5 in the third place of second row. Third element of second row is minus 5. Similarly, find minor of 1, that is delete the first row first column and the third row. So 1 into minus 1 plus 6, which is equal to 1 into minus 1 plus 6, which is equal to 5. So we have 5 here. Okay, it is 5 here. Next is 2. Delete the second column and the third row. Evaluate the minor. 3, 2, 2 minus 1. Its value is equal to 7. So 7 here. Then we have 1. Evaluate that. Evaluate the minor of order 2 by deleting the last column and the third row. So we have 3 into minus 3 minus 9 minus 2, which is equal to minus 11. Okay. Hence, the cofactor matrix is minus 1, minus 3, 7, 3, 1, minus 5, 5, 7 and minus 11. This is not the cofactor matrix. This is an adjoint matrix. Okay. First we write the cofactor matrix, then take the transpose of the cofactor matrix. So this is an adjoint of the matrix. Adjoint of the matrix A is a transpose of the cofactor matrix, which is equal to minus 1, 3, 5, minus 3, 1, 7, 7 minus 5, 11. So this is an adjoint. Now here adjoint matrix is minus 1, 3, 5, minus 3, 1, 7 and 7 minus 5 minus 11. A1, A2, A3, etc. are the cofactors of A1, A2, A3. Okay. Now this matrix is multiplied by a matrix 3 minus 3, 4. So let us multiply these two matrices and then divide by 8. Determinant A is equal to 8. Divide by 8. So we have 1, 2, minus 1. Okay. Minus 1 into 3 plus 3 into minus 3 plus 5 into 4, which is equal to 1 when divided by 8. Okay. So let us multiply the two matrices. Simplify them. We get a matrix of order 3 cross 1. That is 1, 2, minus 1. Now compare it. On the left hand side we have a column matrix X, Y, Z. On the right hand side we have 1, 2, minus 1. So equate the values for X, Y, Z. X is equal to 1, Y is equal to 2 and Z is equal to minus 1. Substitute back. When you put X is equal to 1 here, we get 3. Y is equal to 2, we get 3 plus 2 equal to 5. And Z is equal to minus 1, we get 3, isn't it? So X equal to 1, Y is equal to 2 and Z is equal to minus 1 satisfies this equation. Hence, the solution of this system of linear simultaneous equation using matrix inversion method is 1, 2, minus 1. I hope you have understood this method. So this is one of the direct method of finding the solution of linear simultaneous equation. Okay. Reference book is Dr. B.S. Grewal, Numerical Methods in Engineering and Science with Programs in C and C++. Thank you.